So we'll go ahead and get started today. This is the webinar for the critical role of building envelopes and air movement in CEA facilities. This is going to be a really, really good one. We've got an excellent panel today. Let's get started. We've got a lot of information to cover. Next slide, please, Carmen. Helping me out today is Carmen Azzaretti, the operations and engineering manager, engineering operations manager, RII. She will be the wizard behind the screen, behind the curtain, helping me out today and occasionally chiming in with answers to our poll questions. So let's start off with a poll. Answer this anytime during the next few minutes. We'll leave it up on the screen. What kind of facility are you cultivating in? That'll really help us and our panelists target their speaking to the right kind of audience. Next slide, please. Here's our agenda. Going to have 8 or 9 minutes of introductions and some context. Then we're going to jump into our technical discussions. First one will be on common mistakes for indoor farms. Second one will be greenhouse design considerations. Third one will be common mistakes for greenhouse. And this is all about envelope design and air movement, of course. And then critical role of shade and thermal curtains. And lastly, we'll hear from Caleb Hayhoe on incentives from ICF that apply to the California market. But we're glad everyone's here, not just from California. Next slide, please. Okay, we'll move into introductions. Next slide, and I will have our panelists introduce themselves. I'll start with myself just real quickly. Again, you heard my name and title. My background is in greenhouse management in a plant science research setting. So, Adrian, can you start by introducing yourself and a little bit about what you do?
Sure. It's great to see everybody. My name is Adrian Giovenco. I'm the founder and CEO of Inspire, and we supply cultivation infrastructure and HVAC systems, industrial process automation, and managed services to support profitability of cultivation businesses across North America.
Thank you, Adrian. Matthew?
Hello, everyone. I'm Matthew Paris from Arco Murray. I'm a project manager in our Arco Controlled Environments division. We are working across the United States building these large industrial greenhouses for leafy greens. We also do cannabis facilities and production facilities as well. Happy to be with you guys to share a little bit of knowledge about greenhouses.
Thank you, Matthew. And Ton, who is, just got to say this, it's 10:30 at night where he is in a hotel room. So we so appreciate him being here today. Go ahead, Ton, introduce yourself. Are you muted, Ton? I don't hear anything yet. Okay, we'll move on. We'll move on, Thomas, to come back to Ton. Thomas, can you introduce yourself? And Kubo?
Yes, by all means. First of all, thank you very much for me participating in this event. So Thomas van Dusseldorp, I represent the Kubo Group of the Netherlands here in the USA. I'm a regional director, and our company, we design, manufacture, install, and support operate state-of-the-art glass greenhouses.
Excellent. Can't wait to learn more. Caleb, can you introduce yourself?
Yeah, hi everyone. My name is Caleb. I'm the program manager for the 2 ag programs at ICF. And I'll go over some of the incentives that we're offering.
Excellent. Appreciate it. Let's go back and see if Ton, is your microphone working?
I hope so. Can you hear me?
Okay, please. If you could introduce yourself, that'd be great.
Yeah, so my name is Ton Habraken. I work for Ludwig Svensson as a greenhouse climate consultant. Svensson is a company which is the producer of climate screens. The company is based in Sweden, and we are already producing those climate screens for more than 40 years. We provide screen solutions for glass houses, plastic tunnel houses all over the world to provide a better climate for plants and also for the people who work in there.
So glad to have you here. A lot of times when we're talking about building envelopes, shade and thermal screens are not talked about, whereas my opinion has been that's part of the building envelope, an important part. Next slide, please. Thank you for those introductions. We'll get into a little context about why we're here today and who RII is. The learning doesn't stop at the end of this presentation today. You can access the California Virtual Classroom that RII has put up, which has our recordings from the live workshops we have done. This is the third in a series of 4. Also on that virtual classroom are tip clips and downloadable resources, including our best practices guides. Next slide, please. We've got another workshop coming up on October 26th, Trust But Verify, Commissioning CEA Buildings and Systems. Something if you're thinking about, if you're building soon, you really do need to come to this, because commissioning seems to be something that often gets, is the first thing to kind of be pushed to the side when everyone gets excited about opening up buildings. So don't do that. Don't do that. I can speak from experience. Next slide, please. So part of what we do at RAI is education, such as this. And the way we start with that is by making best practices guides. We put together working groups of industry folks, academics from the universities, engineering, local governments. We put together these working groups. We have several meetings, then I distill that expertise into these guides. We also combine that industry-informed content with the new academic discoveries from the plant science community, and then some of the engineering advancements as well. Try to put it all in one place. And the other thing we do besides that education aspect is we do benchmarking. So growers, crop producers can come to us. It's free of charge, and we can set up an appointment with you. We've got a platform called PowerScore, and we can help develop your KPIs for resource efficiency. Now, what's cool is we've been doing that for a long time now, and we've got a good reputation for being accurate and for being trustworthy with the data. And that's allowed us to generate some of the first data from CEA facilities by 12 different companies across the US. And that's called the CEA Energy and Water Benchmarking Report. Again, it's not hundreds or thousands of facilities, but it's the first time anyone's published data that comes from utility bills. So it's not guesses; it's actual numbers. Great. Next slide, please. Here's some of that data that we collect with our Power Score. If you're interested in doing this. Energy consumption, water quality, and of course production, because it doesn't do you any good to be resilient if you go out of business. So we are looking at your productivity and giving you productivity KPIs. All right, next slide, please. Poll alert. Go ahead, Carmen. Do you have results of our first poll?
Yeah, so it looks like we have a pretty good spread between small indoor warehouse and then semi-sealed air-conditioned greenhouses that people are growing in, as well as a couple of people, or one person who's doing container farms or pots.
Nice, thank you.
So a good range.
Yeah, it is. That's perfect. Next slide, please. Okay, we're going to move into our first speaker for our technical discussion. This will be Adrian from Inspire. The topic will be envelope and air movement design considerations for indoor farms. Before we get started, though, let's do another poll. What is the typical size of the room? What is the typical size room do you work with? So if you will leave that up on the screen while Adrian starts his presentation. Adrian, take it away.
Thank you. Great to see everybody again. Thank you for the introduction, Rob and Carmen. Before we get started, just wanted to, on behalf of Inspire, thank RII and SCE for hosting us today. And especially want to thank you for taking the time out of your day for joining us. I'm going to talk about 4 general topics: air tightness and vapor barriers, building envelope best practices, effective duct design, and eliminating microclimates. And although, I mean, honestly, each one of these topics can really be almost a webinar in and of itself. So I'm gonna do my best to go through some critical design elements that are really going to help, and some best practices. And those seeking a deeper dive, get in touch. I'm happy to set up a call and dive into these topics further at any point. And feel free to pop questions into the chat as we go, and we'll have some time to be able to address those in the chat or live later on. So why do we do this, right? We build sealed indoor cultivation spaces for a reason, right? And that's to be able to truly control the environment and the conditions that are most optimal for the plants that are being grown in those spaces. You know, we're trying to avoid crop loss associated with inconsistent climate or changing climate conditions and any airborne contaminants and natural disasters and on and on. So it's, if we're going to do that, then we're, you know, and we're spending money to create these environments. We want to make sure that we can truly control these environments. You know, we're focused in these facilities on quality, consistency, quantity of the production metrics. That's really what we're here to try to optimize with these controlled spaces. You know, the climate inside of the room should be independent of the exterior and outside conditions in these scenarios. And that's really, you know, one of the big reasons why we're doing this. So as far as air tightness goes, positively pressurized spaces will allow for the cultivation rooms to be clean and not allow any pest or pathogen pressure to come inside of those spaces via infiltration. You know, and that room pressurization is just not possible without a tight room construction. We're then being inefficient with the HVAC and energy and CO2 usage if we're losing air out of the room significantly. We're spending money for that CO2. If we're gaining moisture through openings in the ductwork or other places, we're making that system run harder or not being able to be as effective as it was designed for, or we're dumping air and you know, energy that we're spending out into the atmosphere or other places, parts of the building. So those are all reasons why we want to make sure that we have tight construction and tight ductwork design. There's something that we're seeing used more and more often during the commissioning process, which is called a blower door test, to basically go in and effectively check and see how tight that space is. And it's definitely something that we recommend being added to the commissioning list. I'll jump in a tiny little bit and talk about some, you know, vapor barriers and building envelope. It's going to be fairly high level. It's really important to understand and to dig into when you're putting a facility like this together, you know, and really learn what a vapor barrier is, what, you know, why it's needed, where it should be applied in indoor facilities. Matthew may touch on this some more in his section as well. You know, but we're trying to avoid, like I mentioned, that loss or gain in an uncontrolled way of moisture or heat, or, you know, it can enter or leave that space depending on what is going on. If we jump to the next slide, I can go through just a couple of best practices that we see in indoor facilities. The material selection is extremely important. So metal and polymers versus wood and drywall. The floors should be sealed so that you're not, you know, you don't have uncontrolled moisture movement into the floors, in and out of concrete. Epoxying, sealing the walls and making sure that all the seams are well sealed is really important. And we kind of, what we talk about and practice and preach is a culture of clean in these facilities all the way around. And so we're trying to minimize any sort of foreign object and debris. Like I mentioned, positively pressurizing these spaces to keep them as clean as possible. We're filtering and cleaning all of the air that's coming into these facilities. You can kind of think about it in a way as a cascade, and not designing for a cascade from kind of clean to dirty spaces. And you're more focused on early part of the plant process to make sure that those spaces, particularly tissue culture, clone spaces, mother spaces, are the cleanest in your entire facility, and then move to dirtier from there. And it's really important to ventilate the interstitial spaces. That's something that we see missed a lot. And then you have uncontrolled moisture from interstitial spaces or ductwork. If we move on to the next slide, we'll talk some here about effective duct design. proper system sizing. If we're going to try to deliver air in the right temperature and relative humidity and CO2 and filtration combination, it's really important to have what's called an integrated HVAC system. If you have many different units that are doing cooling here, in some cases heating, dehumidification, all dotted throughout a room, either in the room or outside of the room, it's very difficult to target the temperature and relative humidity and CO2 concentration air that you're trying to deliver to the underside of the plants and where the plant stomata lie. If you don't have a direct, a means to direct that air in that right air environment to those locations. So that's what an integrated HVAC system is and allows for, particularly when we're moving to vertical farming type of growing arrangements. Every one of the layers that you see in this 2-level arrangement on the right-hand side needs the same type of air condition provided to it. And it's very difficult to do that if you have units throughout the room providing different air conditions in different places throughout. As far as the actual duct design goes, you spend a lot of money on the systems, typically less money on the duct work, but it's one of those things that where this like the concept of law of minimums applies, which is like the graphic on the bottom is more for nutrients, but I love just the graphic of it in general, because it's this thought that like even some of the most cost-effective or least expensive parts of your facility can drag down the rest of the facility design and the systems that you have spent money on to get in place. So it's really important to engage the right type of mechanical engineering and contracting resources to get it designed properly, installed properly, and commissioned. And there's many engineers and contractors out in the industry now that have 5+ and up to 10+ years of experience designing these types of facilities specifically. It's really important to engage professionals that have done it before and are not learning on your dime as you go through it, right? There's enough knowledge out there in the engineering and construction community to be able to do it the right way the first time and not have you end up spending your hard-earned money and budget for your project helping others learn this industry, because it is in general a fairly new market, and there's more and more design and construction professionals getting involved in this trade all the time. We in general see a lot of positive results from a room design that's shown similarly to what's on the screen here, which is really a single pass of a front to back type air movement in a laminar type arrangement. In this case, on the right-hand side of those graphics is what would be called the working aisle inside of a cultivation room. And we really advocate for, 5-6 feet at least, if not a little bit more of space in that area to really be used as a mixing chamber. As such, we're delivering that cool, dry, CO2-rich air down into that working aisle and using that as the mixing chamber to then send it down through the racks or tables, however that the cultivation environment is set up, with supplementary fans and air devices, which we'll talk about in a moment, and then returning that air from the back wall back up into the air handling units themselves. Those air handling units, and however that HVAC system is being provided, controlled, can be outdoors. They can be on the lids of the rooms like they're shown here. They can be up on the roof. They can be in a vertical arrangement in the hallway. There's a number of different configurations and ways to be able to do that. Really overall what I'm highlighting here is this airflow arrangement in a single pass type of range We're delivering in general a pretty high number of air changes, 20 to 30 air changes per hour type of range. That's a full mixing and air change every 2 to 3 minutes in general in these spaces. So ultimately, it's a lot of air, and it's really important to make sure that that air has the ability and is assisted with whatever fans and ductwork and air diffusers and everything that are installed to allow it to go through that air path that you have designed. I think if we move on to the next slide, I'll talk a little bit here about eliminating microclimates. And again, this is one of those scenarios where like the ductwork that I mentioned, it's a very low, small cost and portion of that overall budget for the facility, but it's really only, it's one of those places where you can end up really not being able to take advantage of that expensive system that you put in. And conversely, this is not something that, yes, it can help to mitigate microclimates and help environments out that are underperforming, but it's not going to be, if your system is fundamentally undersized from a dehumidification perspective, you're not going to be able to make up for all of that just by adding airflow. It'll help, and breaking up microclimates always will help. And so this is one of the lowest cost and least, let's call it low hanging fruits that you can add if you don't have any sort of in-room air circulation in an indoor space, because it is very inexpensive to add. And even for facilities that are power hungry and don't have a whole lot of extra power, these little fans don't take a whole lot to do that, and like those little fan and tube type of arrangements. But it's not going to overcome, where we talked about earlier, and right sizing and understanding what the true load is of that space and getting yourself the right amount of dehumidification and air conditioning equipment that you need to maintain those conditions. The goal here with in rack and in row air distribution is to break up the boundary layer and be able to and make sure that you're getting that cool conditioned CO2 rich air through the plant canopy. I can't tell you the number of facilities that we see where particularly in the upper tier has, just upper and lower tiers have very different conditions between them, because we've not been able to, be more surgical about the way that the air is delivered there. So it's really being able to eliminate microclimates with airflow in a smart, strategic way can have a really big impact on your overall production metrics. I think with that, I'll pass it off to the next.
Thank you, Adrian. Great presentation. I loved your talking about boundary layers, bringing in that plant physiology into your presentation. And I loved your culture of clean, emphasizing that as part of the team development of facilities. Real quickly, what is an interstitial space?
Oh yeah, an interstitial space would be the space between outside of the cultivation rooms that are built, and between that and the larger skin of the building. In most of these cases, it's inside of a warehouse or another type of a building, larger building. You're building rooms within that larger space. And so this is the space that's kind of, think about it, above the ceiling, but below the roof line.
Great, thank you. And thanks again for your presentation. Carmen, can you give us the results of the poll?
Yeah, it looks like everyone here is working with a larger room size. Pretty much everyone said that they're working with that 1,000 plus square foot space.
That is great to know. That's why we love these polls. Thank you so much for that, Carmen. Next, we're going to move on to Thomas's presentation of the greenhouse design considerations. Before we get to that, we'll ask another poll. What role do you play in the cultivation space? If you can answer this for us while Thomas is doing his presentation, Thomas, why don't you go ahead and start yours? Looking forward to it.
Yeah, thank you very much for the introduction, Rob. Carmen, there will be, let's say, a few next slides that will require to click through. I think we'll point out for himself. Yeah, the initial request was to share some thoughts about airflow in greenhouse, right? And having discussed it with Rob, I thought let's take it a step back and make it a bit broader. Airflow is part of what makes an overall good growing environment. And let's me take it a bit further back because why am I here? Why am I representing this domain, the CEA domain from the Netherlands? The US versus Netherlands. I mean, we're peanuts. We're extremely small, right? So geographical size, 237 to 1 in size. A large difference with population. However, when it comes to fresh produce export, we're close to what the US does. And how do we do that? That's the horticulture domain that started developing right after the Second World War, an industry that was born more or less out of necessity. Supply lines were cut off, people needed food. We started to protect a little bit our crops, and that actually developed into what you see on this from the internet stolen picture of the Westland, an area in the Netherlands. It's all glass that you see. And yeah, an art that was really perfected, always room for improvement, of course, but to what it is today. And today we are exporting this technology. So my role is, my mission here is, of course, to sell products, but also to help initiatives like from Rob's, help education. We have knowledge and experience to share to people considering developing in this beautiful domain. Next slide, please. What is really good to keep in mind, we can talk for hours about technology, but in the end, we're all trying to make money with cultivating produce, whether it being whatever kind of produce. So for us, the plant is really, we are plant nerds. We want to make the environment for a plant ideal, so it can grow well, so it can regenerate well, and make the perfect crops, which ultimately we all earn our money with. And that plant is actually very simple. It's a product of Mother Nature. It needs a few basic ingredients. It needs sunlight. It needs oxygen of CO2, and it needs water. It's not much more to it. And what we try to do is, let's say, help Mother Nature a bit in, let's say, in creating an environment for that plant in which we really can cultivate 365 days per year of consistent quality. Next slide, please. This is where we have to start clicking. So how we normally go about, so we have Mother Nature. Mother Nature decides when what grows where. And we want to, let's say, prolong that for the entire year. So we have a crop requirement, and a grower has an idea where he or she wants to cultivate a certain crop. But that can be anywhere in the world, from I don't know, let's say up into Maine down to California. And those climates, of course, are substantially different. What we do is then, let's say, from a location, see what is the average climate conditions, plus also the extremes. Now, this is a graph from a recent project that we worked on. This is about temperatures, what the averages and extremes. If you click 3 more times, please, Herman. Temperatures, they can change. So we not just look at it at the moment in time. We also look over, let's say, at least 10 years, how possibly temperatures could change, because there may be opinions of climate change. But with looking at data, one could see patterns in there, and that may be a reason to develop a CEA facility, not just for this very moment, but perhaps already anticipating for what may happen with how the climate could possibly develop. because a facility should easily take 25 years, should last for 25 years, and then you need to look forward. So temperature, min, max, average, relative humidity, of course, extremely important in the daytimes, in the night times. Extremely important is, of course, how much light does a location get? Because we Mother Nature could give 1,000 watts per square meter. That's about 95 watts per square foot. We really want to get that energy in, but that varies on the location of the globe. Now and then, it may well be that we need additional sunlight in the shape of today LED lighting. Or if it's too much, we need screening, of which Tom will explain later everything. Next slide, please. Then we're talking about technology, but we should apply technology smart. As I said, this industry was born out of necessity. Every dollar you have to invest, at least you have to earn back $1.50. It could very well be that not for all crops or situations applying technology is worthwhile. So we will always see, we'll continue to see open field growing. And if you continue to click Carmen about 8-9 times, it could also very well be that, let's say, plastic covered greenhouses would work well, or let's say simple greenhouses above mid. But then right up corner at one of our greenhouses we built in California, challenging climates, large. The bottom low picture, you see another project, an urban greenhouse. That could also be a solution. Or at the far right bottom, of course, fully indoor closed. So there's various ways how we can, let's say, cultivate food depending on the conditions, type of food, etc. Then the next slide, please. Next slide. Besides the type of growing condition within those, and now I'm a bit more zooming in to our expertise, the large-scale glasshouse CEA facilities, there's a lot of technology in there. The way we, for example, bring ventilation into the greenhouse is extremely important. The way we heat and condition air is extremely important. And you see here a picture whereby we do not just condition, we not only heat, but we also generate our own electricity that we could possibly share to the grid. Then there's irrigation systems, highly complex lighting systems, screening. More and more we see robotization. That will be the future. Labor will be scarce. And robots can work 24/7. That also goes for internal transport, and of course, not to forget the importance of the means of controls that we have. Computerized systems, more and more fed with AI, learning, finding narrative and data, and help these meantime very highly complex facilities to operate actually autonomously. That's the way we're going to. Right? Not being dependent on people anymore, allowing everybody to grow, irrespective of background and experience. That's where we need to go. Then the next slide. Then there was something about, because that was in essence the initial request, air control, how do we go about it? This is a slide where I would like to bring you along with a concept that we have developed since the past 15 years. It's actually an American idea that we as a Dutch company with our American party developed to what it is today. We call it the semi-closed concept. This is actually a concept that within a glass greenhouse that would allow you to capture as much possible sunlight, free sunlight from Mother Nature, for the photosynthesis process and for the cultivation of the produce. But keeping the nasty, the stuff that you do not want in your greenhouse out. But if you then close it more or less, then you have a problem, because that a good flow of air over your crop is essential. essential. It needs to be homogeneous, of course, throughout the modern facilities are 60, 70 plus acres nowadays, to ensure that every plant is getting the same conditions as everywhere. The semi-closed concept, this is the main difference with the traditional Venlo greenhouse is, and I call it influence over control. A traditional Venlo, you have your roof windows, and depending on what Mother Nature does, you can or cannot create ventilation through your greenhouse, essential for the growing. But you are dependent on Mother Nature. We close it, and by fans and tubes, we force the air through the greenhouse. And by the ability of full control over that flow, we also have full control over conditioning that air that we will feed the plant. That has proven to be highly successful. Most greenhouse vendors or suppliers have adopted this technology and is now being brought to market. So a few highlights over this technology. Carmen, just feel free to click. There's about 10 items. So we have an active and controlled airflow. As Adrian also indicated, we have it's very important that you maintain overpressure. So we keep diseases, etc., everything, we keep it out. Air distribution is homogeneous. So a plant here or 300 feet down the alley will get the same quality air. Because we close it, we can be extremely efficient. That means in terms of energy efficiency, the way we treat this air, we can do it with very low quality heat. So even waste heat, let's say 100 degrees Fahrenheit, we can already use 110 for heating. CO2 control, quite essential. With this technology, we are in the situation, and we have already done that, create carbon negative greenhouse facilities, carbon negative. That will be the future. That is the future, we think, besides our road to becoming energy neutral, but we're not there yet. So all that, we create the ideal crop climate, and that's what it's in the end it's all about. Because let me be honest, any investment in technology, again, I keep repeating, it has to pay back. Right? So with this technology, we can create a surrounding whereby we can ensure consistent quality and yield year-round and in any climate. And that is especially for the US, with vast areas where climate is not easy, even challenging, or sometimes really just bad for crop. With this technology, we can now grow. We can grow anywhere. And the next slide. Then the title says it. It's and I'll reflect back to where we came from. I know it's a very cheap picture. Apologize, but I need to make a statement here. In the end, it's about the crop. You can apply technology, but in the end, you need to have a healthy and sustainable business case, right? Any dollar you put in, it has to be in balance. You have to earn back with bell peppers and lettuce and whatever. Yeah, with that, I would like to conclude my brief presentation. Thank you for your attention. You're on mute, Rob. Rob, you're on mute.
There we go. Thank you. It's an inspiring story when people learn how advanced the Netherlands is in greenhouse production, and they wonder why. Well, the answer is it's a response to the tragedy and suffering of World War. And it's a tribute to their ancestors that they've made such an incredible, they're such a powerhouse for food production. I love that. I love learning about that. Thomas, I got a couple quick questions for you. I really appreciate your presentation. For a grower considering to build a new greenhouse range, is there a minimum size for the semi-closed greenhouse, given the investment you talked about?
Yeah, there's not an exact direct answer because it's all about the balance. There's many ingredients on the left, and there's not just one answer. What can be stated in general is, let's say, the smaller the greenhouse. I mean, there's several costs that will still be there. So economy of scale would state that, let's say, the larger you build it, the relatively relatively cheaper it will be.
Yeah.
But it could very well be that a small greenhouse for medicinal cannabis, for example, let's say, I'm just making up rough numbers, don't pin me down on it, but let's say a 2-acre greenhouse, high fletch could work out perfectly, bottom line. Whereas a 20-acre tomato greenhouse, for example, in certain areas would really struggle doing a good math on that.
Interesting. That's a great point. The value of the crop would justify the size of the facility. Second question is, how can North American growers train their growers and their mechanics to operate this new technology?
Well, I think there is a very interesting challenge for the educational system in the US, for universities, craft schools. I mean, this is a domain that's now rising. It's being developed, and not just from scratch, but right away, top-notch technology. And I think that's actually very interesting to appeal for new students, because today we're seeing that farming is almost considered a dirty word, and I hate to hear it, but nobody wants to get their hands dirty anymore. But with the new greenhouses, which have such a high level of optimization, I think this will be different there, I think the level of technology could actually appeal to students. So to answer your question, I think this domain must make itself known, what is all possible, and hopefully it will attract good students. And then, the universities, of course, they will have to have their faculties, their CEA faculties, get good knowledge in. And as a domain, we can share our knowledge on the short term.
That's great. Thank you. That's great. And I worked at a university for 20 years, and you're so right. The students were being drawn back in. CEA was helping to draw back in students because of the technology and because of the sustainability. Every one of those students wants to do something to improve the planet, and so it's pretty inspiring. So I like how you're bringing that together, that this could actually be a benefit to universities because the technology will attract more students.
Rob, if I may add, and I'll just not keep them too much longer of your time, I'm relatively new to this industry. You mentioned, so I'm actually from the oil and gas industry. So since only 4 years, I'm now in the CEA. And what appealed to me is that, like my previous occupation, where I more or less had done everything that I could do, it has to be international, it has to be high tech, large complex projects. And I found it exactly in this domain, with the big difference indeed, that with this technology we can do good. With this technology we really can have, let's say, everybody have access to affordable, fresh produce. And that's why I'm in it. Definitely I can imagine that it will appeal also to new people in the game.
Right. Well, thank you. And I'm glad you're in the industry. Thanks for your presentation today, Thomas. Carmen, you want to tell us about our poll?
Absolutely. It looks like we mostly have people who are consultants or advisors, with a couple of equipment providers and vendors. So people who are advising, which is a great group of people to be educating.
Yeah, then that extends our reach from these. So we appreciate it so much. Oh, and I also want to add, in addition to, as Adrian reminded us, you can put your questions in the chat and we'll address those. But also I want to remind you, we're recording today. This will be available on our RII website, which Carmen will put that in the chat. And we get a lot of traffic for this recorded module. So just want to let you know these will be available. So if you have to duck out, don't worry. Okay, next we're going to have Matthew do his common mistakes, greenhouse envelope for envelope design and construction. Before he does that, I'm going to do another poll real quickly and let him get started. Next slide, please. Do you use any of these textiles in your greenhouse? This is a question kind of setting us up for the final segment about whether or not you use shade or thermal curtains. So we'll leave that up, and I will turn the microphone over to Matthew. Go ahead, Matthew, take it away.
Thanks, everybody. First of all, I want to thank Thomas and Adrian for great presentations. You kind of set the stage for me today. I've been lucky enough to be a student in this industry for the past several years, kind of hopped on board the same time as Thomas here. It's been an incredibly rewarding industry to learn, and I share some of the same goals and ambitions as you do, Thomas, about providing local produce, technology that's actually useful. And I feel like in this construction industry, it's one of the most rewarding and satisfactory jobs that I could think of, which is why I'm attracted to it. And I'm excited to talk to you guys a little bit about, the different style greenhouses that we've seen here in the US as they've become more popular, taking those many, many years of knowledge and expertise from the Netherlands and bringing them here to the North American states it's just a great overall thing, great partnership that I think we're building here in the US. And I hope to see many more of these greenhouses in North America here to come. We have a lot of land to fill up with acres under glass. So I'm going to talk to you guys just a little bit about the materials that we use to build these greenhouses, and also more importantly, for me, in my role here in this industry, is the support buildings that really support the plants, provide you the necessary space to package, harvest, and store these plants as they're coming out of the greenhouse. So just to start a little bit, to give you a basis of knowledge, a lot of these greenhouses that I've seen here in the US are the Venlo style, maybe with the semi-closed technology that Thomas has been talking about. And then we have, in addition to those greenhouses, we have what I call the head house, or the support building, which basically provides all of the necessary equipment to harvest, to package, refrigeration, storage, all the necessary items that the customer or the client in this case would need us to provide them in order to have a successful business plan. So a lot of these things use very similar materials. From the greenhouse side, we see galvanized and coated steel and aluminum extrusions, as well as glass. That is the basis of design and the envelope of the building. It doesn't really get much more complicated than that. And when you're building your support buildings to these structures, you can choose to use a pre-engineered metal building with girders and joists, or you can use sort of a Venlo style head house too. We've seen that with the similar roof peaks and similar design as the greenhouse. So you can see on the right just a couple of photos. The bottom right photo, I think, paints a really good picture of how you can transition from a glass greenhouse into an insulated metal panel roof. You can provide different functions with the same type of structure, all really work very cohesively together. And we, here in the bottom left, we can show you a rough design of a pre-engineered metal building. And I'm going to chat with you guys a little bit about, the considerations you might think of and the mistakes you might make if you're not considering the head house and the functions that it's supposed to perform. So the biggest thing in my mind for designing a support building that's going to really supplement and provide a good support to the greenhouse is the roof height, the insulation values of the roof and walls, the waterproofing, the water tightness, and in this case, you guys have mentioned the air tightness of the structure can be really, really important. There's a lot of items like mechanical equipment, HVAC, ductwork, lighting that you need to consider inside of the head house. And the room layout is also extremely important for reasons that Adrian mentioned, with interstitial spaces, the amount of area that you need for harvesting and packaging, the level of automation that we're incorporating into these buildings, as Thomas had mentioned. All of those are very, very important. And one of the most important ones is really the roof height and the loads that you're designing for. Several structures here that we use, such as pre-engineered metal buildings, have very large spans because it can reduce the overall cost of the head house. This mistake has been made several times, but one of the things we consider here at ARCO is how much equipment is actually hanging from that ceiling? How much process piping do you have? How many mechanical units do you have? And when you're installing a fire protection system, how much spacing is required between those supports? If you're using, larger girders with larger spans, it can become really, really challenging to find space to install all of your MEPs to have the proper support that you need in the right clear span. So we haven't perfected this by any means, and I'm sure there will be many iterations, but we've trended towards using almost a stick build with HSS or I-beams columns, and then also girders and joists spaced pretty closely together for the ceiling to give you enough space and enough shorter clear span to hang mechanical equipment and piping from. So by going with a cheaper structure, you may not actually end up saving money in the long run, depending on what's required for getting all of your mechanical units in the building. One of the other big ones is, the type of building you're using and the air tightness and water tightness. The envelope of this head house can have a significant impact on everything underneath. First, I'll start with a really important point Adrian brought up, which is mold, mildew. The ability for that building to breathe and bring in outside contaminants, and to bring in outside moisture. We really like to see an airtight and a very waterproof structure in our support building. One, for food safety, and two, for giving us a climate in the area that we can really control with the mechanical equipment that we're installing. So we can go to the next slide, please, and I think I'll give you a little bit more context on that. So it really is about the customer. We have to be able to run these buildings efficiently, and we have to be able to turn a profit at the end of the day for this to be a successful project. So the owner and the end user or the operator of this facility is going to have a huge impact on the size of the building, the type of the building, and how much space we need inside of the support building for these head houses. That's one of the things that we really dive into deep here at ARCO to provide a really great project and a really great facility for our customers. We try to understand their business at the core level, and this is going to influence even the earliest stages of our design here for these head houses. We are still going to be using very similar materials across all our projects. We likely see steel or coated steel, all non-combustible construction for the most part. We focus on the strength and the span of all of our overhead girders and joists. We consider the waterproofing and overall just the functionality of the space. I look at the building envelope as not just the walls and the roof, but also the floor, as Adrian had mentioned. It is very, very important from a food safe standpoint, and it kind of takes different forms as you move across the country, depending on the climate that you're building in, the operations that you're trying to achieve in these spaces. So I do take all sides of this envelope very seriously in my early stages of design, all built off of the client expectations and their overall business plan. One of the things that I'd like to chat with you guys about is just really the insulated metal panels. I saw there was a question that came in from one of the attendees here. So on the top right, this is just a standard section of the insulated metal panel. These are pretty common material building types. You can get different kinds, tongue and groove, some that interlock, but for the most part, they're very adjustable. You can get custom sizes, custom lengths, custom widths, and even custom colors to create that brand that your client is trying to produce. So the insulated metal panel is a great construction material for the walls and in most cases the roof of these building envelopes. There's different thicknesses and different variations between the different products, but for the most part, this is what we see as the primary wall structure and even roof structure for these head houses. They do provide some challenges that we have seen go wrong in the past. One, it sometimes can be difficult to waterproof these structures. They're more of a living, breathing organism, kind of like the greenhouse. But that can pose challenges for the head house where you're looking for clean environments, you're looking for that air tightness, you're looking for that water tightness in certain areas. So the considerations of insulated metal panel in various places of the building can be really significant to the overall design. And in the bottom right, just as an example, you can see how, there's mechanical fasteners, there's many seams, there's different material types coming together at the roof line on a Venlo style insulated metal panel head house or greenhouse that really need to be considered on the overall building envelope. On the left, I provided just a quick picture of, the concrete walkways that you can see in these greenhouses. I really like to focus on this because with a great floor, you can either spend money up front for a very good drainage system, a very nice finish on your concrete. You can create all kinds of floor coatings on these floors to make sure that you're providing the building and operator a clean space to work and a very efficient space to work. By sloping concrete, adding drains where you need them, eliminating concrete where you don't, and keeping access open for future maintenance is an incredibly important part of this design in the building envelope. And I would just say that when you're designing the concrete for these facilities and you're designing the draining systems, the end user should play a major role, and you should be consulting with the end user and the operator to say, how much of this is going to be automated? Where are your major clean areas? How can we prevent the expense of maintenance over time in these facilities by making it easy to clean, making it having a really great drainage system, a great sewer system that is going to reduce the overall maintenance that you need. So that is a huge part of the envelope. And under the greenhouse, that can take several forms. You can either have a concrete floor under the greenhouse, which is common in areas that have unsuitable soils, or smaller footprints. You can also have open floor greenhouses with ground cloths and covers for areas that have different soil conditions and that have different drainage systems. So again, the floor is a huge part of the envelope. I think we're good to go to the next slide. So one of the things that I've learned being a student of this industry over the past few years is when you see your first greenhouse start operating, it's almost like it's alive in a sense. It lives, it breathes, it transfers heat, humidity, almost like the human body or the plant. It has its own kind of characteristics depending on where it's built, what materials it's made out of, and what it's growing. So it's really simple to me, if you look at it through that lens, you just need to design accordingly. You can't assume that it's going to be a static environment. You can't assume that everything is going to remain in place and not shift over time. When I think about the design, I imagine, this thing fully operating and all the different climates that are happening in all these rooms and the considerations that we take for our architectural features, our exterior building envelope, and the end product are all taken into consideration with this in mind. We have to assume that these buildings are going to move, they're going to expand, they're going to contract, they're going to respond to Mother Nature and what she's doing. And one of the things that I wanted to discuss a little bit today was how this impacts the construction of these facilities. So to give you an example, the climate is held pretty steady in the greenhouse during production. Once the mechanical systems come online, once the networks are established, the commissioning is completed. But during construction and prior to the building coming live, greenhouses are basically just a furnace. They take the sun. The greenhouse can be 150 degrees on a hot summer day. There's special considerations you have to take into when you're building these facilities, and it's not always straightforward. And if you install, steel in the wintertime when the steel is contracted, it may expand in the summer, and you may have tightened bolts. If you install in the summertime and you check the bolt tightness in the winter, you could have some loose bolts and connections. So the building moves quite a bit, and it changes even throughout construction and as you make your way into the final days. So just wanted to tell everyone to keep that in mind. Some mistakes have been made, in the past during construction, not considering these things, and they really do impact the overall bottom line of construction. In addition, food safety and washdown, we've talked a lot about good drainage, good sealant on your floor slabs, good sealing from your slabs to your walls, and then the waterproofing overhead from the roof. All very, very important for food safety. And different clients will have different levels of food safety that they need to achieve. So keep that in mind as well. Typical things that we design our envelopes to accommodate are harvesting, processing, packaging, a lot of the irrigation and fertigation equipment, silos and tanks that our team Kubo would provide, and then storage areas, shipping areas, docks, everything listed here you could see in a CEA facility, but it's not always the case. So that's why we have to be very in tune with what our owner and what our client is trying to provide to their business. Things to consider. Go back just one more real quick, unless I'm running out of time. Other things are just when you're designing this envelope, like I mentioned earlier, the rooftop units or the condensing units, if they're going to be hung from the ceiling, that is a big part of the envelope. The refrigeration areas, as we were talking about earlier, box inside of a box, basically, creating an interstitial space between the top of a refrigeration system and a refrigeration cooler and between the roof. So the roof height of these structures, the storage that you need to get within a specific size footprint is very, very important for the building envelope. Fire suppression, water distribution, lighting, all those things taken into consideration with the building envelope. We can go to the next slide. So I was talking a little bit with Thomas about this ahead of this call, but there's a common mistake, I think, is just either over design or under design. It can go either way. The idea is to find that nice, delicate balance between adding too much and not enough. We like to try to help out in that as much as we can in this industry. We try to steer people in the right direction. We manage our designers closely to not lose sight of what the actual end goal is. And that starts with the building footprint. That starts with the size, the complexity of the structure, and what we actually need to provide. We talked about the clear spans and the joists and girders. Humidity is obviously a big issue, especially as you're going from a humid climate in the greenhouse to a refrigerated space just next door to a dry storage area. I mean, there's just so many different, I'm going to call it microclimates within the head house and within the greenhouse that you need to consider in your building envelope design. Drainage and sloping is a big one. Again, I think I've talked enough about that. The extreme temperatures, I had a little photo here on the bottom right showing a close-up picture of the vents that Thomas was talking about earlier. You would think that opening these vents and getting good ventilation in the summertime in a greenhouse that's in the middle of a field would help, but not always. Until you have that climate established in the greenhouse, the vents can only do so much. We can only get so much ventilation there in the greenhouse. So it's a consideration that can really trip you up in the construction side of things for how hot that greenhouse can be. And coincidentally, an insulated metal panel head house tends to hold its cool temperatures really, really well, even during the summer. So there's a huge transfer of heat and energy going on at almost all phases of the construction, and it changes quite a bit. I think another issue is just undersized rooms and maybe poor planning, from an operation and the way you move throughout the support building and throughout the greenhouse. It's very important to get your spacing and your design for your layout completed early on. And then in all different parts of the country here in the United States, we deal with seismic considerations, wind considerations. We have hurricanes on the East Coast. We have tornadoes throughout the Middle East or the Midwest, sorry, and earthquakes out west. So there's so many different considerations to take into account here in the U.S. These greenhouses can be designed and manipulated to accommodate almost any climate. That's one of the things that's really unique about these structures. It's really a unique solution to the food crisis we find ourselves in. And I just see so much potential to capture these problems, to improve the overall business here in the U.S. and continue to grow these facilities.
Thank you, Matthew. That was great. I was so glad you brought up combustible components or envelope materials. because I know that acrylic glazing for greenhouses has caught fire before, and there's been large companies, I believe Pioneer, which is now Corteva, Pioneer's greenhouse in Iowa. They lost a lot to a burning of the acrylic cover of the greenhouse. And also, I was amused because it's happened to me when you talked about a greenhouse under construction is like a furnace. Another thing that can go wrong for design is that you shouldn't be using PVC, Schedule 40 PVC, because by the time we got into a greenhouse after it was under construction, like you said, the temperatures had gotten up way beyond the specs of Schedule 40, and it was all bent. It was up in the rafters for an irrigation system that just was drooping because it just had gotten too hot. So great points.
Right.
Carmen,
Yeah,
go ahead. All right, Carmen, let's do you have a poll response? Okay, you want to let us know what happened?
Yeah, it looks like we didn't have as many responses to this one. It looks like we only had a total of 5 respondents out of everyone who attended. But it looks like most of the respondents had used the combination shade and thermal curtains, while 1 each had used shade and 1 had used light diffusing shade.
Great, awesome. That sets us up well for our next presentation. So that will be the critical role of shade and thermal curtains. Before we jump into that, I'll do another quick poll, and then we'll let Tom take it over. So please select the types of webinars you are interested in. We're thinking about changing up some of our formats for 2024, and we'd love to hear your opinion. Okay, next I will turn it over to Tom to talk about shade and thermal curtains. Take it away, Tom.
Well, thank you for having me and inviting me for this webinar. I would like to start also a little bit more about my background. I was born basically in this industry. My father was a Gerbera grower, and I was born in the Venlo region, the city of Venlo. I went to school there, and that's also where the Venlo greenhouse basically has originated. So yeah, I cannot imagine being outside of this industry, because it keeps on developing and new things are happening, and it keeps me also very excited of this industry and where it's going. Yeah, in this webinar series, already in the first webinar, my former and much appreciated colleague Robert Hannafin has already explained a lot about the possibilities of climate screens in a greenhouse. So you can use them for saving energy, for shading, so letting less energy into the greenhouse, for blocking the light leaving your greenhouse or blocking the light coming into the greenhouse. So several possibilities, and yeah, a lot of those screens, they also improve your R value, so they improve the energy efficiency of the greenhouse. So these climate screens, they can improve the greenhouse climate and the plant growth a lot, but if you use them in the wrong way, then they can also do quite some damage, and then they can give some unwanted results in the greenhouse. And yeah, as this webinar is about air movements, I would like to focus a little bit more on that part, about the right usage of the screens and the results which can come from that. And to start with, I have this image, and also the priority one, the title of the slide. Make sure that once you build a greenhouse, you get as homogeneous greenhouse climate as possible. It is pointed out also by the previous presenters that homogeneity is very important. And as you see in this example, in this measurement of a greenhouse, you see warm spots and you see cold spots. The blue spots are much colder than the red spots. And yeah, if your measurement box from your climate computer is hanging in a spot where there's the red or orange color, then you might think, well, everything is going okay. But then in the spots where there's the blue color, it's too cold, and therefore maybe even way higher in humidity. And that's where you can find possible problems with your plants. If we go to the next slide, you see the results from temperature differences on the relative humidity. So in this example, 5 degrees temperature difference in Celsius, 5 degrees Celsius in temperature difference results in spots where the relative humidity is 80%, but there are other spots where it's 98%, and that's where you might have problems with fungi, botrytis, other fungal diseases. But at the spot where it's quite a bit warmer, your relative humidity is really low, and the plant is maybe demanding more water. So the temperature might not be the biggest problem. It's most of the time the humidity resulting from it, which gives you problems in plant quality. And yeah, these temperature differences in almost all greenhouses, there are some temperature differences, but we want to keep them as small as possible. So if we go to the next slide, you see that, yeah, also because of the design of a greenhouse, we basically already create temperature differences in a greenhouse. We designed the greenhouse in a slope, and that's of course to get rid of the rainwater to the side of the greenhouse. But because of the slope, and in greenhouses we work with warm and humid air, the warm air always will have the tendency to go to the highest point into the greenhouse because warm air rises. Then if you also have a screen in the greenhouse, and in the screen there are gaps, then at the warmest spot in this greenhouse, the warm air will go up into the attic of the greenhouse. It will cool down against the glass. It will roll down all the way to the gable, and through the gaps in the screen, the cold air will drop into the greenhouse back. And this causes a continuous loop of air going round and round and creating, in this example, temperature differences of up to 5 degrees Celsius. What growers traditionally tend to do to solve this problem is increase the temperature even more, or sometimes they also have lights being switched on in certain periods of the day, and this brings even extra heat into the greenhouse, and this increases the temperature differences even more. So this is basically something we do not want. This is something we want to improve. So if we go to the next slide, growers get, because of these temperature differences and this continuous loop of warm air, cold air going up and down through the greenhouse, this might result in retarded growth at the colder spots. And if there's really cold, the plants really get cold, there might even be condensation problems in the greenhouse. So that's something we do not want. Well, we can do something about that, and that's if we go to the next slide. For example, install the vertical screens above the horizontal screen. The vertical screen in this picture are the green lines in what I call the attic of the greenhouse, and we divide the whole length of the greenhouse into 3 separate sections, and therefore the air above the screen in the attic cannot roll all the way down back to the gable, but it is divided into 3 different sections, and therefore you've got a smaller loop of air going round through the gaps in the screen, and this results in only 2 degrees temperature difference, while in the previous picture we had a 5 degree temperature difference. So this is already a improvement in getting better and more homogeneous climate. Next slide, you see some examples of pictures of this apex seals, of these vertical screens in a greenhouse. When they are being installed, you have to make sure that these materials are also tight, that if there's the greenhouse clean out, that you do not blow them away with high pressure cleaning. So it has to be a tough material, and also because air is quite heavy. So 1 cubic meter of air, it weighs 1.3 kilogram at sea level, roughly. So that when there's air movement above the screen, also quite a lot of force is being pushed onto these apex seals. So therefore also it has to be tight material. In the right picture, you see that they didn't only install apex seals above the screen, but they also closed the trolley, the truss, in between, so that there in this greenhouse there are 2 screens, and also in between the two screens, air can start rolling down all the way to the gable, creating temperature differences. So here in this example of this rose greenhouse, they installed, besides the apex seals, also seal in between the screens in the truss to seal it off tightly. In the next slide, you will see also the results. So you get a way more homogeneous growth, smaller temperature differences, but also very important is that you do not or apply the screen gaps as less as possible. So if we go to the next slide, that's also one of my advices. Oh no, sorry. First, even though you have installed these apex seals, so the green lines in this picture, and you're venting above a screen with screen gaps in it, the influence on the wind of the greenhouse can result in temperature differences. So the wind in this case hits the gable, it moves up and it continues, and at that point it creates under pressure, so it takes out all the warm air out of the greenhouse. Because of the under pressure above the greenhouse, inside there will be also a under pressure. So this makes sure that inside the greenhouse you get a opposite direction of the wind direction, so an air movement inside, and this creates also again a under pressure in the middle of the greenhouse, so near the main path, dragging in cold air into the greenhouse. So although you have these vertical seals above your screen, the wind can make sure that you still get temperature differences, but then in the other way, then the gable in this case will be warmer, and there can still be temperature differences of 5 degrees Celsius. If we want to improve this, then we go to the next slide. Then, traditionally we install horizontal airflow fans to battle this problem of temperature differences. But yeah, as I explained, when the wind hits the greenhouse on one gable, internally we get a opposite wind or air movement. These horizontal airflow fans, we normally install them like a snake inside the greenhouse. So one goes the one direction and the other goes the other direction, up and forth. But yeah, as the internal air movement also goes in one of those directions, half of these fans are battling the internal air movement, but the other half are helping the internal air movement. So we cannot expect that horizontal airflow fans will solve this problem of temperature differences. Next slide, please. Also, if the wind comes from a other direction, so more in an angle towards the greenhouse, then the throw of a horizontal airflow fan will be bent off, and therefore it will not reach the next fan, and therefore also, yeah, the air will not be distributed from one side to the other side, and also in this case you do not solve the temperature differences. Next slide, please. So it's better and to take out the influence of the wind, and we can do that by fully close the screen. So we shouldn't apply screen gaps, because of these screen gaps, yeah, air, as I showed you, can go up and down at other spots, but that's something we do not want. So we should work with the screens as they are mentioned also, as they give also the highest energy saving value, by applying them fully, and do not apply screen gaps in there, because then the wind has no influence on the internal growing climate, and we are much more in control, and we get a better and more homogeneous climate. But as we seal off this greenhouse more and more, and there's less wind influence, we do want to create air movement, controlled air movement inside the greenhouse, because that gives us the active climate, as we call it. We want the active climate to take humidity out of the canopy, and also to break the boundary layer, as mentioned by one of the previous presenters. Traditionally, we do this with a heating pipe, creating convection going from the bottom to the top in the greenhouse. But that's an energy expensive way of creating air movement. So it's way better to control this air movement and get this air movement going by vertical fans, which create air movement through the canopy and taking the humidity out of the crop, and then it can be discharged through the screen, for example, by condensation on the glass. Next slide, please. So this vertical air movement is very important to take the humidity out of the crop, but also to break the boundary layer, as also explained by one of the previous presenters, so that it's easier for the plant to evaporate, but also you bring the CO2 closer to the stomata. In the right picture, you see one example of those vertical fans, which can help you in creating activity in the crop without having to put in the minimum pipe in the greenhouse. Next slide, please. But then, of course, crops also produce humidity, and humidity is sometimes one of the reasons why we do traditionally apply screen gaps. Yeah, of course, through screen gaps, you could discharge humidity more easily, but it's better to have more control over what nature normally does with screen gaps. So there are ways to automate the screen gap. And in this example, you see a screen fan. This one is called a ventilation jet, and it replaces the need for screen gaps. So you take fresh air from above the screen by a fan, which is in the white envelope. It brings the fresh air into the growing area, and inside the greenhouse, the fresh air is being mixed with the greenhouse air. And this way you can have more control on your temperature and on your humidity level in the growing area. So this is a way to automate the screen gap and to have more control on your greenhouse climate. And this way you also create a much more even greenhouse temperature. Next slide, please. Yeah, here's one of the of a greenhouse with of these fans installed, and we want the throw of one fan to reach the throw of the other fan. So this way you also get a vertical distribution of the air in the greenhouse, horizontal distribution of the air in the greenhouse. Next slide, please. So if we apply these principles in a good way, then screens will definitely improve your greenhouse climate, and you can get really high energy savings with 2 screens up to 70% of energy saving. And for the homogeneity of the greenhouse, we can move also from situation A to situation B, where we have a way more even greenhouse climate, way more even humidity distribution, and therefore also the plants can grow in the same way everywhere. And that's very important if we want to move towards autonomous growing, because the intelligent algorithms, they also have to be, they have to rely on the data they get. So therefore, everything needs to be as even as possible. So this is also important, moving towards data-driven growing. That was the presentation I wanted to give about the usage of climate screens and how they can help in creating a more even greenhouse climate.
And this is a great presentation. It's exactly why we wanted to have a webinar on building envelopes and air movement, because air movement is a complex topic. And I think we often don't understand that. And yet, one of your very first slides, Tom, of the humidity profile, that heat map, it was actually a water vapor map, shows why. You can see that part of the greenhouse's relative humidity was 62%, another part was 98%. There's just no way you can have a successful crop time after time again if you have that sort of non-uniformity. And it's more than just equipment you buy, it's how you understand air movement. And it can't always be solved but just by horizontal air fans, which is something that a lot of people believe. So that's great. We're going to skip over our poll results since the last poll was just for our use. We're going to go to Caleb Hayhoe for his incentives overview. We'll probably skip our question and answer. I don't see any more questions in the chat, so that I want Caleb to have enough time to explain what's going on with the ICF incentives, because you're going to be very interested in these. Go ahead, Caleb.
Thank you, Rob. So my name is Caleb. I'm the program manager for the 2 ag energy efficiency programs. I work for ICF. We're the company that's in charge of implementing the programs. There's two programs. We have an electric program and a gas program. And I'm just going to go over some of the incentives that we're offering right now. So starting on the electrical side, we have some deemed measures. Deemed measures are a lot easier to work with. They're based on a unit quantity, say square footage of a greenhouse or horsepower of a motor, and they're paid on a predetermined payment amount per unit. So you can see on the electrical side, we have glycol pumps normally found in wineries. We have horticultural lighting. Right now, the horticultural lighting, unfortunately, does not cover lighting that covers actual plant growing space, but it will cover anything in a head house, a hallway, a storage area, or an office space. And then further, ICF is actually working right now to expand the work paper related to horticultural lighting so that we can soon include plant lighting, which will be a really big deal because obviously the greatest power user is the actual plant lighting. We also have ventilation fans. Right now, this is in dairy production. And then we have VFDs on well and booster pumps. Next slide, please. So continuing on with the electric program, we have custom measures as well. Custom approach or the custom pathway allows us to customize everything much more, and it allows us to work with equipment that doesn't already have a work paper designed to make it a deemed measure. So on the electrical side, this includes lighting, HVAC, refrigeration. The refrigeration measures can apply to post-harvest processing as long as that processing is done on the same site as the plant production or the crop production. Next slide, please. So some further custom measures for the electric program. We have irrigation measures, compressed air measures, pumping measures, and then some wastewater measures. You can see the incentive itself for custom measures is paid on a kilowatt hour and kilowatt savings basis. So based on the kilowatt hour savings, you'll be paid 15 cents per kilowatt hour. And then any additional kilowatt demand savings, you'd be paid an additional 150 per kilowatt. Next slide, please. Okay, so moving on the gas side, some of the deemed measures that we offer on the gas side include steam traps, storage water heaters, different varying degrees of efficiency in process boilers. You can see that on the gas side, the incentives are broken out into three categories. There's the standard rebate measure, which would apply to anyone. There's the increased rebate for DAC customers, which is based on a kind of similar to zip code classification done by the state of California. If you want to see if you apply, just go ahead and Google see Cal EnviroScreen 4.0. That'll actually let you open up a map so you can see whether or not you're DAC qualified. Then the last third column is for HDR customers. These are customers that meet a certain list of qualifications. You can reach out to me, and my email will be at the end. See if you qualify for this. And this does have the possible option of installing no cost, which means that you would not have to pay and install the equipment up front. You would simply allow us into your facility to come in and install the equipment at no cost to you, either for labor or materials. Next slide, please. So some further deemed measures that we have on the gas side include tank insulation and fitting insulation, as well as pipe insulation. Again, these are broken out by the three incentive categories. And as you can see, they all have their own requirements. Next slide, please. So the last of the deemed measures on the gas side include both greenhouse heat curtains and then greenhouse IR film, both replacement of existing systems or new construction. And again, these are broken out by standard DAC and HTR rebate levels. Next slide, please. So just finishing up on the gas side, some of the custom measures that we offer include boiler system upgrades, greenhouse environmental controls, IR space heating, potentially ozone cleaning, and then just general greenhouse retro commissioning. These are paid, again, it's based on a savings amount. So this is based on the number of therms being saved, and it's paid out either as a standard incentive or a DA incentive. And HTR customers would fall under the DA incentive as well. Next slide, please. Just really quickly, some of the basic requirements for the measures. You have to meet the general program eligibility requirements, meaning you have to be a customer of one of the two utilities. All the equipment must be new electric or gas powered, depending on the program you're applying to. Then the equipment itself generally has to be bought within the same year that it is installed. So say you bought equipment last year in 2022 and you want to install it this year in 2023. In most cases, it would be ineligible, but there are some exceptions. So if you're in that case, again, feel free to reach out to me and we can clarify whether or not you'd be eligible. And then lastly, everything has to meet Title 2024 standards. Some of the delivery services that we offer, training and education on broader benefits, including non-energy benefits. Along with RII, we have building energy assessments, energy benchmarking, everything that RII offers. And then again, we do provide dedicated outreach specifically for DAC and HTR customers. Next slide, please. So just to finish up, here's my email. I also have the email for Ben Cooper. He's the other program manager. He works for NSAVE, who contracts with ICF to run the program. If you have any questions, feel free to reach out to me anytime. And thanks, Rob, for having us.
You bet, Caleb. So glad to hear about your incentives. Great programs. Carmen, let's skip to slide number 62. And we'll wrap things up here. I want to thank Southern California Edison for sponsoring this workshop series. And I want to thank today's experts, Adrian from Inspire, Matthew from Arco Murray, Tom from Ludwig Svensson, Thomas from Kubo, and Caleb from ICF. For Carmen Azzaretti, I'm Rob Eddy from Source Innovation Institute. Thanks for attending today.